Let me tell you how capture might have formed the moon now. So what might have happened in capture is the Earth was probably sitting here early in its formation, and then some big piece of rock might have been flying by with some speed v, some velocity v. Then what could have happened at some point is the Earth's gravitational pull might have started to pull this object towards it here, remember, with our force of gravity that we discussed. And if the conditions were just right, then the delicate balance might have been achieved, and this object might have started orbiting the Earth, gravitational capture. Maybe that's where our moon came from. So let me show you how that could happen here. Here's that gravity simulator that I showed you before. And so everything's kind of nice and processed here. Here's the Earth and here's the moon, but just pretend this moon is like a big chunk of rock. And it's possible then that this piece of rock was just sort of humming along this way. And I'll turn the path on so you can see the effects. But of course, as we know, if I turn the gravity force on, the blue arrow you see coming off the moon is the Earth's pull on it. So here we go. Let's see what happens. So the object's humming along. Here we go. And looks like we did not capture it. Okay. So we can go back then to something like this, and let's say that the object is up here again. Here's the velocity, but say maybe it was going a little bit slower, and maybe something like this. Again, it could be coming from any old direction, but I'll just sort of keep it up here. I'm just slowing down the velocity a little bit. Let's turn it on, see what happens. We'll watch the path. It's kind of fun to do. And here we go. And did we capture it? No, didn't quite capture it. Now it's possible this one's going to return again, but we'll won't wait for it here. All right, let's just try that again. So here we go again, and I'll say it's up here. Maybe I'll just slow it down even more. So maybe it was coming in something like this. Looks like I've got the path turned on. So here we go. Are we going to capture this? Yeah, it looks like we are. So see the really cool effects of gravity like that. In this case here, we have captured this object that is otherwise flying by. It doesn't have the orbit our moon has. Our moon's orbit is much more circular. In other words, it doesn't get as close to the Earth as this one seems to, and then doesn't get as far from the Earth. And you can see it definitely perturbing the Earth as you go. But I hope you agree that we did gravitationally capture this object. So that's what capture then would be all about. So the next one that we see is condensation. And that's this idea of sticking rocks. Let's see what that one's about. So I have a bit of a video clip for you here. So what these pieces are here, of course, it's Play-Doh, nice yellow Play-Doh, but they're meant to represent rocks that were flying around the early solar system. So we might have had a situation where a bunch of rocks were all floating around in the early solar system. There's evidence was a very messy place, just rocks whizzing by each other like this and this. And once in a while what might have happened is two rocks might have come together and collided like that and made a bigger rock. Now again, as I mentioned in the video, it's difficult for me to imagine why rocks would have been so sticky, but maybe they were molten and sort of in a soft lava state, or maybe they just collided with each other so hard that they just, parts of them just fused together under the warmth and heat of the collision, just like that, and they just really stuck together like that. In either case, that's what would have happened, is these rocks would have collided like that and sort of stuck, and maybe another rock would have been coming in from this direction, collided right there. And then something sort of interesting happens as the rocks get kind of bigger, then gravity can start to take over. So maybe like this rock over here may have wanted just to pass right on by like that, but instead as it came by, it got gravitationally attracted to this growing rock right here, so got even bigger, right? And here's a really big chunk coming by right here that also might have just flown off into outer space all by itself, but it got over here gravitationally attracted into there again. And so you can see these really large sections of rocks might have started to form even more. They'll just like making that noise. But a very large rock might have happened like this, and this might have been where our moon came from. Collection of a lot of rocks, and don't forget, as one gets larger, gravity would have even sucked more rocks, and then maybe wouldn't have even collided with it. But that's the condensation theory. And I say again, the only trouble I have with it is where did that stickiness of the rocks come from? Because if I get two rocks from outside, they don't seem very sticky to me. But again, maybe they're warm in the molten state and were kind of sticky that way, or maybe large collisions just cause them to pulverize and fuse together, you know, no matter what. Okay, that's condensation. Little idea for you there. So that's condensation for you there. And so the last theory then is ejection. And what ejection is about, as I sort of mentioned, the Earth might have been sitting here minding its own business, and something really large might have been coming directly out like that. In other words, a direct hit. It was just coming right in, and it just might have been, when these things sort of hit here, a massive collision. And what would happen in the collision then is, of course, as this mass came in, like this, well, I can't get the effects to happen at the moment, but the massive collision might have come right in. This rock would collide with it, and then a lot of stuff would have just started to fall out like this. Just after a big collision, just all this stuff might have started to come out, including really large sections of rock like this that used to be in the Earth, and then maybe this section of rock might have been gravitationally captured and formed our Earth. So ejection is about something after a collision being thrown out of the Earth, and the video I'll show you about that next will illustrate that.